Carlos, is a mechanical energy conserved?
Yes, it is.
Why?
Because even though the kinetic energy and the potential energy change, the sum will be always the same due to the principle of conservation of energy. Alfonso the architect sent us a case where two girls went to buy a slide, so we gotta make the formulas for that case.
As we know, Dr. Carlos, mechanical energy needs gravitational potential energy and kinetic energy. In this case, the kinetic energy is equal to 0 because we start from rest. And in the point B, substitute the values that is mass times gravity times height over 5. And this is the GPE in the point B. The kinetic energy in point B is mass times gravity plus 4 over 5 height. And the GPE in the point C is mass times gravity times height equals 0. That is the same in the GPA. And the kinetic energy in the point C is mass times gravity times height. To find the kinetic energy, substitute mass times gravity times half height over 5 plus times gravity plus 4 over 5 height. So substitute m mass times gravity times 4 over 5 height plus 1 over 5 height. So this is the kinetic energy in C that result mass times gravity times height. The GPE in the point B and the kinetic energy in the point B have a result, so is the kinetic energy in B, that is mass times gravity times 5 over 5 height minus height over 5.
Then the GPE and the key of A, B, and C are: from A is mass times gravity times height, the kinetic energy is 0, the GPE of B is mass times gravity times height over 5, and the kinetic energy is mass times gravity times 4 between 5 of height, and the GPE of C is 0 because the height is 0, and the kinetic energy of C is mass times gravity times.
To have the velocity in the point B, use the mechanical energy. As we know, the gravitational potential energy is mass times gravity times height, and the kinetic energy is equal to 1/2 times mass times velocity squared. So it's laid and clear for velocity B, that is equal to square root of 8 over 5 gravity times height.
Then for getting the y max, we have to substitute t in this formula, and t we got is this. So substitute y max is equal to over this formula. Then using the previous answers, we simplify this formula and we get this: 9.8 times the sine of theta minus 4.9 times the cosine of theta times this plus the height between 5.
3.
Then in statements, the initial velocity is the square root of a between 5 times gravity times the height. And the horizontal speed at y max in terms of h, g is over this. And the other part of D. Using the previous answers, we simplify and get 9.8 sine the sine of theta minus 4.9 the cosine of theta times time to the square plus height between 5. So are we going to have the same answers with friction?
No, because friction is again motion, and for that reason the velocity decreases.
Oh, okay, so that's all. Architect, I hope this is useful for you. See you in the next
Here you go.
Hi, thank you so much. It's
Yeah.
beautiful.
Another satisfied customer.
Yeah.